In this recording, we're going to take a look at a simulation of confidence intervals. So I'm going to create a confidence interval for a population proportion. So what I've done is I've created a population that has a population proportion of 50%. And from that population, I'm going to take samples of size 30, and I'm going to construct for each sample a 95% confidence interval. So let's see what happens. So let me explain what we're looking at. So what we've done is we've done 100 intervals. For example, let's take a look at this interval right here. In this interval, we got a sample proportion of 40%, an upper limit of 0.575, a lower limit of 0.225. Let's take a look at another interval. So in this interval, the dark dot indicates the sample proportion. So we can see that this one has a sample proportion of 0.43, a lower limit of 0.256, and an upper limit of 0.611. Now you'll notice that many of the confidence intervals are green, but a few are red. So let's take a look at a red interval. So let's look at this interval right here. This interval had a sample proportion of 0.7, a lower limit of 0.536, an upper limit of 0.864, and you can see that it did not capture the population proportion. The population proportion was 50%. It's represented by this dark line here in the center of the graph. And so the red confidence intervals are the ones that did not capture the population proportion. Now, if you look at this graph, we can see that there's only 1, 2, 3 red intervals. So out of 100 intervals, 97 of them did contain the population proportion, only 3 did not. So that means that 97% of the time, this method worked. So when we create a 95% confidence interval, what we're saying is about 95% of the time, it should work. It should capture the population proportion, and in this simulation, it did. What happens if we were to change the sample size? So for example, let's take a look. Instead of using a sample size of 30, let's use a sample size of, say, 100. What do you think is going to happen to the interval width? Okay, let's see if your prediction was correct. So we'll do 100 intervals. Can you see what happened to the interval width? The interval width got smaller. So by increasing the sample size, what we've done is we've decreased the width of the interval. So the intervals become much more alike with less variation in them the larger our sample size. So let's take a look. And again, we can see the vast majority are green. In this case, 1, 2, 3 are red. So again, 97 of them do contain the population proportion, and 3 do not. So this idea of creating a 95% confidence interval means that this method we're using should work about 95% of the time, and we can see that it did. So that's an example of simulation of what it means when we create confidence intervals.